Hi guys, today we're going to go over complex numbers. So in this section I will go over the definition of a complex number and its conjugate. I will go over some basic operations, and of complex numbers and the printable square root of a negative real number of a complex numbers. Finally, I will go over some natural numbers of powers of I, or imaginary. So let's go over the definition of let's go over the definition of a complex number. So, a complex number is a number of the form a plus bi. This is also called the standard form, where a and b are real numbers and I is called the imaginary unit. So an example would be 5 plus 6i or 2 minus 3i. So yes, the 5 and 6 are all real numbers. Okay. So here are some simple operations of complex numbers. So let's go. So here's some basic operation of complex numbers. So one of them is the equality operation. It's pretty simple. A plus bi equals c plus di. If and only a equals c and b equals d, right? Yeah, so pretty simple. A goes with c and b goes with d. Okay, that was the equality. Number two is the addition property, and it's pretty simple. So you have an a plus bi plus c plus di. So that would be a plus c. Notice that the a goes with c, and then the imaginary goes together, right? The b plus di. So that's why it's a plus c plus b plus di. B plus d, and that's your imaginary number. And the multiplication is pretty simple. It's self-explanatory. You just do the you FOIL it out. And so if you have a plus bi times c plus di, do your regular FOILing, and you should get ac minus bd, and then ad plus bc times I. So those are some of your properties of complex numbers. Let's see. So let's do a product of a complex number and its conjugate. So let's say you're given this, a plus bi times a minus bi. We know that this is, well, okay, so let's say, so if you multiply, we know this is a perfect square. That's why you get a squared plus b squared. Yeah, a squared, so yeah, a squared plus b squared. Yeah, so this is a perfect square. So my question is, what is the conjugate of a plus bi? What is the conjugate of that? So the conjugate of a plus bi is a minus bi. It's almost the same thing, but there are sign changes. What about the conjugate of a minus bi? The conjugate of that would be a plus bi. Pretty simple. And yes, we need this rule when we solve some perfect complex numbers. Okay, so now the square root of a negative. So the printable square root of a negative real number. So it's really simple. The principal square root of a negative real number denoted by negative square root of negative a, whereas a is a positive, is defined as. So all you have to remember, you cannot have a negative inside the radical. So what you do is you factor out an I. That negative becomes an I. You factor that out, so it's going to be I times square root of 8. The same thing with here with the square root of negative 3. can't have that negative, so you just factor out an I. So that's pretty much a square root, the principal square root of a negative real number. So yeah, no negatives inside the radicand, factor out an I. Okay, now we're going to deal with natural numbers power of I. Takes on particularly simple form. So here's some rules for I. So I is just regular I. Remember this rule is because this will pop up a lot. I squared is equivalent to saying -1. I cubed is -1. I fourth is just +1. I 5 is just I, because I 4 times I is 1 times I. I 6 is -1, and then I 7 is -I, and then I 8 is just regular 1. So you kind of see the pattern. You go from I to -1. So this is 2 is an even degree, so 2 is -1. 3 is an odd, and you're going to get a -I. And then 4 is an even, so it's going to be the opposite of -1, so it's going to be +1. 5 is odd, and you know that this is, your last odd was -I, so it's going to be a +I. And then I6 is -1 because our last positive was 1, so it's going to be a -1. So it's just pretty much the opposite, right? So these are some rules, and then you're going to get into like higher order. So like you were going to have to find I to the 58, right? You got to figure that out. So what you have to do is you pick a number that you already know. So we like how about not I to the 50, like I to the 60? How to figure this out is pretty much you can rewrite that as I. What do we know? 6. We can rewrite I60 as I6 raised it to the 10th power, and that we know that I6 is -1, right? And you just have to raise that to the 10th power, and we know that -1 to the 10th power, I think it's 10 is what? Even, right? It's good. So your answer is going to be 1 because the degree is even. So that's how you do like really high order imaginary numbers. So let's actually do some problems. Okay, so my first problem it says the problem asks us perform the indicated operations and write each answer in standard form. So we have a 3 minus 4i minus a -5i plus 6i. So we're just gonna have to perform the operation. So we're subtracting. So first off, I'm gonna just FOIL out this negative. So let's FOIL out that negative. So over here you have two negatives, that becomes positive. Over here you have a negative times positive 6i, so that becomes a -6i. Bring down your leftovers, which is a 3 minus 4i. Now we're going to group like terms. So let's group all the real numbers. So our real number is like 5 and 3. So 5 plus 3 is 8. Now let's collect all the imaginary numbers. So I'm going to circle all the one with i's. So this is going to be, I'm going to circle this one. And then I'm going to circle this one. So that's going to be -4 minus 6 is 6, 7, 8, 9, 10, -10. And then this is what's called a standard form. Standard form is like a plus bi, right? So this is my final answer. Let's do another one. same rule, gotta perform the operation and then put it in standard form. So this one is 1 plus 2i times 3 minus 4i. So we know this, we got to multiply this one out. Now, is this one of our special rules? Is this like a perfect square, perfect trinomial? Nope, it's not. It's not. So what you have to do is you're just going to have to FOIL it all out. So it's going to be 1 times 3 is 3. 1 times negative 4i is negative 4i. 2i times 3 is 6i. 2i times negative 4i is negative 8i squared, because we're multiplying the i's as well and the numbers. So let's simplify. We know that, remember from the last rule, we know that I squared is a negative 1, right? So we'll multiply negative 8 times negative 1. Let's bring all this down. Negative 3 minus 4i plus 6i. So negative 8 times negative 1 is positive 8. Bring the rest down. So let's group, put it in standard form. So we have an 8 and a 3. So let's box that one. 8 plus 3 is 11. Now let's combine all our imaginary numbers. We have a negative 4 and a negative 4i plus 6i is positive 2i. So that is my final answer in standard form. Okay, so let's do this one. Same idea, same rules. We have to put it in standard form. So let's say I have a 2 plus 9i and then times 2 minus 9i. So we're multiplying this complex number. So I'm looking at this and I know this is what's called a perfect square. And I don't want to FOIL it out because I'm kind of lazy, so I just don't like taking the long way. So what I'm going to do is do the perfect square rule, and if you forgot how to FOIL out this polynomial, you can go back to my videos where it has all factoring rules for factoring and foiling. So this is perfect square, so I know this is going to be 2, my a is 2, so it's going to be a squared, so which is 4, minus b squared, which is 81 squared. Okay, so this is just the rule for perfect square. So it's going to be 4 minus 81. We know that I squared is negative 1. So negative 8 times negative 1 is positive 81. And then bring down the 4. 4 plus 81 is 85. Now you can leave it like this, 85, or you can leave it as 85 plus 0i. They're the same thing. So either answer is correct. Okay, so let's try this one. Let's say you're given 2i times 4i. So if we FOIL this out, this is going to be 8, and then I times I is I squared. Good. So we know that I squared is negative 1, so it's 8 times negative 1, which is negative 8. You can leave it like this in standard form, or you can leave it as negative 8 plus 0i. They are the same thing. Okay, let's do a subtraction one. So let's do this one. So let's say we have 3 plus 7i minus 2 plus 5i. So we got to perform the subtraction. So first I'm going to FOIL out this negative. So that's going to be negative 2. This is going to be negative 5i. Then bring this down. So it's 3 plus 7i. Okay, now let's put it in standard form. So we have a 3 and a negative 2. So that's positive 1. And then 7 minus 5i is positive 2i. 6, yes. So this is my final answer in standard form. Okay. So let's see. Okay, let's do a much more difficult one. So let's say I'm given 1 over 2 plus 4i. So what I'm going to do is I will have to this one. I want to get rid of this. I want to make this 2 plus 4i. I want to take the conjugate of that. So what I'm going to do is first is take the conjugate of the numerator. So this is our denominator. Sorry. Sometimes you have to take the conjugate of the numerator or denominator. So in this case, it's just that ours is going to be our denominator. So you take the conjugate of that, and then you multiply that by. Then you multiply top and bottom. Multiply top and bottom by conjugate. And then just simplify. And sometimes you might have to take it twice. Sometimes you have to take the conjugate twice. So, okay, so what would be my conjugate? So I'll put it right here. What is my conjugate? So we look at our denominator, it's 2 plus 4, so the conjugate of that is 2 minus 4i. Now you just multiply top and bottom by that. So the 1 times 2 minus 4i is just 2 minus 4i. Good. Divided by, now this is what's called the perfect square, so I don't have to FOIL. I'm going to just do the perfect square. So it's a squared minus b squared, and we know our a is 2 and our b is 4i. So 2 squared is 4 minus 16i squared. Okay, so let's simplify. The numerator is probably the most simplified it can be. Okay, so this I squared is the same thing as negative 1 minus 16. So two negatives. Negative 16 times negative 1 is a positive 16. So it's like saying 4 plus 16, right? So that's 20. Now, what you can do is, see this 20, it's dividing the whole thing. So it's like saying 2 divided by 20, and then negative 4i divided by 20. So you have to divide everything by both sides, or what you can do is factor out a 2 and then simplify that. I'm just gonna I'm just going to divide, so this is going to be 2 over 20 minus 4i times over 20. 2 over 20 is the same thing as, if you put in a calculator, it would be 0.1. And then minus 4 over 20 is the same thing as 0.2i. So this is your final answer in standard form. First thing I did is took the conjugate, multiply it by the top and bottom by the conjugate, simplify, and then put it in standard form. So that was one of the harder ones. Let's do some more harder ones. But first, let me erase everything. Okay, so let's see here. So let's do this one. Whoops. Okay, so we have 4 plus 3i divided by 1 plus 2i. So first thing is, I'm going to have to find my conjugate and multiply top and bottom by the conjugate. So what is my conjugate? The conjugate is usually the one in the bottom, and then you just change the sign. So our conjugate is going to be 1 minus 2i, because this one is positive, so you just change the sign. So it's 1 minus 2i. So let's multiply top and bottom by that. Okay. When you FOIL this out, you're going to get 4 minus 8i plus 3i minus 6i squared. And I know this is a perfect square, so I'm going to get 1 minus 4i squared. Okay, so let's see. This I squared can be simplified as negative 1 times it by negative 6. So you're going to get, when you simplify the numerator, you're going to get 10 minus 5i, right? Because you have 4 and you have a positive 6, you get 10, and then you have a negative 8 and negative 8 plus positive 3i is negative 5i. Good. I squared is the same thing as negative 1, so negative 1 times negative 4 is positive 4, so 1 plus positive 4 is 5. Now remember, this 5 means you have to divide everything, so when you divide everything, 10 divided by 5 and negative 5i, you get 2 minus I. So that's my final answer. Okay, so that was that one. Let's do, oops. Okay, let's do another one. You first find it. Okay, so let's do this one. It says convert imaginary numbers to standard form, perform the indicated operation, express answers in standard form. So it was like the last one, right? The last problem. First, so it's a plus, so we just have to collect like terms. So over here, we have a 5 here, and then a positive 2, that's 7. Hold on, before I do that, do you see these negatives? Negative square root 4. Let's rewrite that as 2 minus, remember you can't have a negative, so you have to factor out an I, square root of 4 plus 5 minus, take out that negative, so you factor out an I, so it's I square root of 9. Okay, now we can actually fix this. The square root of 4 is 2, but you have an times it by I, so it's going to be minus 2I plus 5, and then the square root of 9 is 3, and then you have an I, so it's going to be minus 3I. Good. Now let's collect like terms. So we have our whole number is 5 and 2, so it's going to be 7, and then negative 2 minus 3 is negative 5I. And that's your final answer. 7 minus 5I. Okay. So that was that one. Let's do another one. Let's do a multiplication. So the difference between these problems is that they have the square. We have to fix the imaginary. Now, so this is the multiplication problem. So before I FOIL everything out, let's fix the negative square root. So this is going to be a 3 minus. Okay, so let's kind of do this in our head. So you can't have a negative, so you factor out that I, and then it's that, get rid of that. So that's going to be square root of 4. So that's going to be, and then you have an I, so that's going to be, square root of 4 is 2, and then that's 2I. This negative 2 stays the same, so that, so square root of negative 49 is equivalent to saying I square root of 49, which is 7I, right? So it's going to be plus 7I. Now we can FOIL it. So when you FOIL everything out, you're going to get negative 6 plus 21I plus 4I, and then negative 14I squared. We know that I squared is negative 1, times it by negative 14. Okay, so let's simplify. So this is going to be negative 6 plus 21I plus 4I, and then negative 14 times negative 1 is positive 14. So when you collect your whole numbers, 14 and a negative 6 is positive 8, and then 21I plus 4I is 25I. Here's your final answer. 8 plus 25I. Okay, so what about this one? This one, let's see. This one is kind of a long one because you have to take the conjugate twice. So let's say you have 5 minus square root of negative 4 over 7. So before we do this, before we find our conjugate, let's simplify this. So we know that negative square root of 4 is the same thing as 2I, right? So it's going to be 5 minus 2i over 7. Yeah, if you ever get confused, like how I got 2i was, remember, you cannot have a negative, so in that radicand, so you have to factor out an I. And then the square root of 4 is 2, and then 2 times that I, because it's a multiplication. So that's how I got 2i, negative, and then just bring down this negative. So now I got to take the conjugate. So our conjugate is not going to be, remember our conjugate used to be in the denominator. Now the conjugate for this one is going to be on the numerator. And it's just this same thing as this, but different sign. So this is going to be a positive 5 2i times 5 plus 2i. Okay, so let's fix the numerator. When you I know the numerator is a perfect square, so when you do that, when you multiply that, you're going to get 25 minus 4i squared. And then on the denominator, you're going to get 7 times 5 is 35. And then 7 times 2i is 14. Positive 14i. Okay. Let's see here. Let's fix the numerator. So I squared is the same thing as negative 1. And then you have a negative 4. So that negative 4 times negative 1 is positive 4. So it's 25 plus 4, which is 29 over 35 plus 14i. Now, this is the part where you have to take the conjugate again. So our conjugate is going to be, and you multiply top and bottom, it's going to be 35 minus 14i, because it's the same thing as the denominator, but different side. So times top and bottom by this, 35 minus 14i. Okay. So our, let's see, let's fix the numerator. So when you do the work, you're going to get 10, 15 minus 406i. And on the denominator, you have a perfect square. So the perfect square is going to be it's going to be 12 25 minus 196 I square. Okay. So we know that I square is a negative 1 times by negative 196. Two negatives becomes a positive, so it's 1225 plus 196 is 1421. So my denominator is 1421. So it's like saying 10, 15 minus 406 divided by 1421. So this 1421, you have to divide it for the 1015 and the negative 406i. When you do that, you're going to get a simplified fraction. And I already simplified the fraction. It's going to be 5/7 minus 2/7 I. You can leave it like this, or you can leave it in decimal points. So yeah, this one was longer because you had to take the conjugate twice. Oops, I did not erase. What happened? Come on. Good, erased. Okay, let's do another one. Same idea. let's do this one. Let's say you have 1 plus 3i over 2i. We want this in standard form, right? So the first thing is you got to take the conjugate. So what would be my conjugate? It's not going to be the denominator, it's going to be the numerator. So it's the same thing as the numerator, but different sign. So it's going to be 1 minus 3i times 1 minus 3i, right? So the numerator is the perfect square. So when you do the perfect square, you're going to get 1 minus 9i squared over, and when you FOIL out the denominator, you're going to get 2i minus 6i squared. So let's fix the numerator. So I squared is -1 times it by -9. So two negatives becomes a positive 9. So 1 plus positive 9 is 10. Let's see here. The I squared is -1. I'm doing the denominator. I squared is -1 times -6, and then 2i. So two negatives becomes a positive, so it's 2i plus 6. So our denominator is 2i plus 6. Now, are we done here? Nope. We gotta do one more step. We gotta multiply the conjugate again. So this time my conjugate is coming from the denominator, this part. So it's the same thing as this, but different sign. So it's 2i minus 6. 2i minus 6. Now let's FOIL the top, the numerator. 10 times 2i minus 6, that's going to be 20i minus 60. And then the denominator is the perfect square. So the perfect square is going to be 4i squared minus 36. Okay, so the I squared, let's fix the simplify the denominators. I squared is -1, so it's 4 times -1 minus 36. So that's -4 minus 36, which is 6, 7, 8, 9, 10. That's -40. So we have 20i minus 60 divided by -40. So we have to divide this -4 for here and that -40 over here. So when you do that, you're going to get a fraction. You're going to get what we can. Okay, so I should have put the -60 here and then the positive 20i here. That's much better. So when you divide -60 by -40, you're going to get a positive fraction of 3/2. And then when you divide 20i divided by -40, you're going to get -1/2i. Okay, that is your final answer. Okay, what about this one? Yeah, we're doing a lot of problems because I really want you to like grasp the complex numbers. So let's say you have 2 minus 3i, square that, minus 2 times 2 minus 3i plus 9, and then forget about this. So the 2 minus 3i this is a perfect square trinomial, right? Perfect square trinomial. So if you don't remember that, you can check out my factoring video. So this is, when you FOIL this out, you're going to get 4 minus 12i plus 9i squared. And then when you FOIL this out, you're going to get negative 4 plus 6i plus 9. I got the 9 from here. So now we could just simplify. So 9, this I squared is negative 1, so it's 9 times negative 1. Let's see. So let's group like terms. So we have 4 and then negative 9, because 9 times negative 1, and then negative 4, you're going to get, this should be negative 9. Let's see what happens. So we have 4 cancels, the negative 9 cancels as well. So we don't have any real numbers. Now let's deal with imaginary numbers. So we have a negative, let me circle this, a negative 12i and then a positive 6i. Negative 12i plus 6i is negative 6i. Yep, that's your final answer for this one. Okay. Okay, now we're going to do something a little bit different. It says, for what values of x does each hold? I mean, that was a different problems, but okay. So let's say you're given, we got to find let's say you were given I 18, and then we're given I 32, and we're given I 67. We got to figure this out. So what is I to the 18th? What is that going to be? So we have to use what we know. So remember, if you go back to that chart, let me see if I can find it. Go back to, is it this chart? Nope. Here we are, this chart. If you go back to this chart, use this chart and then use only what we know. Okay, so I to the 18th, what do we know? So we can rewrite I to the 18th as I to the 6th, raise that to the 3rd power, right? We know that. We know what I6 is. I6, based on that chart, is negative 1. And then you'll have to raise that to the 3rd power. So negative 1 to the 3rd power is going to give you negative 1. What about I to the 32? So use what you know. So we can rewrite I 32 as I to the 8th, raise it to the 4th power, because when you're raising an exponent, you're multiplying the exponents. So it's really saying 8 times 4 is 32. So we know that I to the 8th, based on that chart, is 1. And then raise that to the 4th, so that gives us positive 1. Now I to the 67 is, let's see, how can we rewrite that? We can rewrite that as I to the 6, right? I to the 6, raise that to the 11. But that only gives us I to the 66. We want 67, so you're going to multiply that by an extra I. So we know that I to the 6, based on the chart, gives me negative 1. If you raise that to the 11th power, times it by I. So negative 1 to the 11th power is negative 1. And then you times that by I. So negative 1 times I is negative I. Good. So I to the 18th is same thing as negative 1. I to the 32 is positive 1. And I to the 67 is negative I. So you pretty much use what you know. We know that I6 is negative 1, and then you could just raise that to the 3rd power, right? We know we can rewrite I32 as I to the 8th raised to the 4th power. And we can rewrite as I67 as I6 raise that to the 11 times it by an I. And we know that I6 is negative 1. And you raise that negative 1 to the 11th power, you still get negative 1. And then you bring down that I times by I, so that's how you get negative I. Okay. I think, let's see, I think we have one more, and then that's it for this section. Let me find it if I can find it. I can't, so the problem wants me to find. So we are given x squared minus 2x plus 2. And then for x equals 1 minus I. Good. So we gotta just simplify this. So they're saying x equals 1 minus I. So let's plug, wherever you see an x, you plug in 1 minus I. So it's 1 minus I square minus 2 times x, which is 1 minus I plus 2. So 1 minus I squared is the perfect square trinomial, right? Perfect square trinomial. Let's see. So we know when you FOIL that out, you're going to get 1 minus 2I plus I squared. And then so this is just if you completely forgot how to FOIL out trinomials, there's a video on that. So now just FOIL out this negative 2. So this is going to be negative 2 times negative 2 times negative I is positive 2I, and then add plus 2. So we know that I squared is negative 1. Bring down 1 minus 2I minus 2 plus 2I plus 2. Let's see if anything cancels. So we know the 2 cancels, 2 and negative 2 cancels, the I cancels, 2I and I, and the 1 cancels as well. So you're left with nothing. You're just left with 0. Okay, so that wraps it up for this section.